Okay, so here we go. If we're going to solve this one, we need a base of 2/3. That's what I'd use anyway. And I just go and write this one as 2/3, just like I want it to be. But then I got to figure out what to put here to make it true. I got to make it flip, and I got to make it bigger. -2 was the key. So x is equal to -2 times 3. X is equal to -6. Raise your hand if you had that one right. That's most of you. All right. So again, find a good base that would work for both of them, and I use that. All right. Next one. This one, it's almost like a personality test. About half of you are going to do it one way, and half of you are going to do it the other way. But most people get it right. Give it a try. I'll move it up so you can see it better. So the two ways were either you could use 1/3 as your base. Oh, I want to use 1/3, so I make it 1/3. But then I got to make it true somehow. And then I got to go, well, I'd have to make it flip, and I'd have to make it 3 times, or to put it to the 3rd power, so that would be -3. And that would make that equal to that, which means x equals -9. That's a good way. How many did it that way? How many did it a different way? All right, and this is the other people. David. All right, if we use a base of 3, then I can go like this. 3 to the x, 3 to the 3rd, and I got to put this to a power, and I got to put that to a power. 3 to the -1 works right here, and then 3 to the what makes 27? 3rd. So it's -x equals 9, and x equals -9. Either way works just fine. So it just depends on how you think. All right, let's look at the next one here. Y equals 2 to the x. That's the black one of these two graphs. And I got the little green dots on there to sort of tell where this thing was moved to. So you can focus in on the green dot. Looks like it's moved how far to the right to get to the red one? 3 to the right, and then what? Up 1. Rewrite this equation so that it'll work for the red one. Mr. R, what would you do to get that 3 to the right in there? You put a -3 up there? Because why? Counterintuitive is why it's negative, okay, and you put a +1 out down here. Why'd you put it on the outside? Yes, the stuff that's on the outside messes with the y's. The stuff that's up next to the x messes with the x's. All right, so that is correct. Raise your hand if you had that one right. All right. This one, we got the red one is the original one. The blue ones are the ones that have been stretched or whatever. Can you tell if this one's just been moved to the right or if it's been stretched to the right? Looking at this one right here. What do you think? Moved or stretched? Moved, because each point moved how far? Exactly 3 spots. So that's just 3 to the right. So if it was y equals 2 to the x, and I want to move it 2 to the right, I just go +2 right there, -2 right there. All right. And now over here, this looked like it's been moved up or stretched up? Stretched. It went up times 3. If you go from 1 to 3, you got to go times by 3. It went from 2 to 6. It's also times by 3. So it's times by 3 somewhere. How do I do it? Times 3 in the front or times 3 by the x? Is this an up-down thing or was it a left-right thing? Up-down. And the stuff that is up-down is on the outsides. So that should tell you that you go right there. All right. And you'll also notice that that becomes the y-intercept in this case. See how 0, 3 is the y-intercept? And there it is. Okay. And if I took this and I wanted to flip it, I could put a negative in front, and it would make it flip which way? Up, down, or left, right? Up, down. If I do an up-down flip, I just want you to be able to visualize this. Everything, like I'd start with this point and flip it over. So there it is. And then I'd say, well, instead of going up, if it's all flipped, it'll have to go down. And then you can just sort of like figure out the rest of it must be like that. All right. So I just wanted to go over what a flip over the x-axis, or it's actually a reflection over the x-axis would look like. Then there's these. Remember these? This is written in a certain kind of form. It starts with an R, recursive. And it's the starting value of what? 15,000. And then every time it goes up by, you multiply by 1.2, and that's called the something something. Common ratio. All right. Now, if you're going to write an explicit formula, what you're doing is you're writing a formula that doesn't need to have all that recursive stuff. And so you usually start with y equals, and then do you remember how this is the end and this is the start? And then it's always 1 plus something, and then it's always a variable up there. This same formula is what we're doing here. Okay, so it's y equals, and then it's the start value, which was what? 15,000. And then it's always 1 plus something, or 1 minus something. What would I need to get this one? 1 plus 0.2. And then what is my last piece I'm missing? To the something. And what usually goes with y as the other variable? X. Okay. So that's how you'd write a recursive formula as an explicit formula. So basically that's your start value. So that goes there. This is still the same. It's just written as a 1 plus. Okay, and the only other thing you got to remember is you got to have the power there. And that's what this whole unit is all about, is exponentials, which have x's in the exponents. Okay. See if you understood that well enough to do this one. Try to write that with an explicit formula. Same kind of formula we used for the haggis, that kind of stuff. Okay, so you start with y equals. Then you need that start value, which is 12. And you always need a parentheses, which is 1 plus a rate. In this case, it's multiplying by 0.8, so I don't know if anybody caught this. You do 1 minus 0.2. And then you need the power, which is there. Raise your hand if you either had this or the 0.8 in there, inside the parentheses. That's almost everybody. All right. That's writing an explicit formula. And to enter it on a calculator, remember the calculator, once you get it in sequence mode, it would come up and look like this. It'd give you those three kind of obscure things. This first thing is almost always a 1 or a 0. What would we use in our case? 0, because n min means these are the n's down here. And what's the n min? Means the smallest n. What's the smallest n we ever had? 0. So we put a 0 right here. And u sub n is equal to u sub n minus 1. And then there's always something in parentheses here. You could just go right to the 0.8 if you wanted to. Or you could say 1 minus 0.2. Either way is going to be 0.8, right? And then the last thing I need is something right here. What haven't I told the calculator yet? The 12. n min is 0. So basically this is saying u sub 0 equals. Well, that's what it wants to know right there. U sub 0 is what? 12. So once you put that on your calculator, it'll tell you multiple terms. So you're going to see that on your homework too. All right, that's all there is to it. So we got homework. It's probably one of the most important ones we've had in several months, because this test is that I got a lot of things on it. It's going to take you all hour tomorrow, and hopefully tonight you take your homework in, you practice, and you check your answers on Blackboard. All right, good luck.